Hello everyone, my name is Chris Morin. I'm going to be walking you through a very basic configuration of RIP version 2. This is one of the earliest routing protocols. It has been in production networks for over 20 years and is still used pretty frequently all over the world. It has very advanced predecessors or successors or whatever word that means, the ones that come after it. But RIP is so relatively easy and reliable that it has a footprint on modern networks today. And because of that, it is still important to show you it as an introduction to modern networking, because this really is the routing protocol that started it all. The outline for our configuration is as displayed here. I have two routers. I'm using the 3725 routing iOS because the 2600 bugs out from time to time. There'll be a link for it in the more info, and I should be popping one up here right now. So go ahead and download that, add it to your hypervisors, and then plop them in there. We're going to have one loopback interface per router, and the loopback interface is going to reference the router number. So 1.1.1.1 is going to be router 1, and 2.2.2.2 is going to be router 2. For those of you who don't know, a loopback interface is created as a virtual network on the router. So you can use it to virtualize, in a sense, a private address space beyond the router. Sort of like, in this case, we're using these as a means for testing out RIP. Router 2 will be able to see that this connection is already there because it's directly connected to it. But router 2 will not be able to see the 1.1.1.1 address that is beyond router 1. So we use RIP in order to give it that functionality. So let's go ahead and start up our routers, and we will let them begin. Now, RIP, as I said, has been around for a very long time, but there's more to configuring a router than just RIP. And if you're watching this, you're probably relatively new to Cisco configurations in general. So the first thing that we want to do on these routers, as we're configuring them, is do some very basic functionality that all routers should have, like being able to telnet to them, and some other things that Cisco just deems as necessary. So they should be done booting in just a few moments. And once they are, we can begin. Alright, so our routers have finished booting, and if you haven't configured your idle PC values, I would suggest doing so now. By the way, if you don't know what this program is, you can go to this video, and I will show you how to configure and install everything that you see here. Your router 1 is basically just a dumb router. It doesn't have any configurations on it so far. I'll prove that to you. I'm not hiding anything. Just run a show run, and I'll show you just the default configurations that are built into the router. So that is pretty much it. So the first thing that we should do is go into configure terminal and give this thing a little bit more functionality. We want to use the no IP domain lookup command. That makes it so that if we accidentally mistype a command, it doesn't try and think of it as a host name and then try and look for a server to resolve that host name. It wastes about a minute of our time every time we make that stupid fat finger. Another thing we need to do is give it a enable secret command. I'm just going to give it a password to Cisco. This makes it so that anytime I enter the enable user prompt, I will be prompted for a password. Another thing we need to do is the service password encryption. This makes it so that if I type in any password that was sent as plain text, it will not be displayed as plain text in the show run config. It's much more secure that way. Now we go to line VTY04. VTY is your telnet sessions, and you have 5 channels that we're currently configuring right now on our router, and we want to make it have a password too, so we can reach it. Let's keep it Cisco as well, and you use the login command to require it to use that password. And that's pretty much it for basic configuration of a Cisco router. I'm going to go ahead and do that on router 2 really fast, and then I'll resume the video. Okay, now that that's done, I'm going to go ahead and configure our interfaces. The first one I'm going to go ahead and configure is our loopback interface. You do that with the interface loopback. We'll just do 0. Give it an IP address of 1.1.1.1 and a subnet mask of /32, making it the only address available. Also note, with loopback addresses you do not need to do the no shut command, but I do just as good measure. It's a good habit to get into, even when you don't need to do it. After that, let's go ahead and go to the interface S00, which is our serial interface, and we want to give it the IP address 10.0.0.1 and a subnet mask of /30. I keep making that typo up here. Look at that, /32. You guys are probably yelling at me looking like, that's wrong, you did that wrong. Oh right, well you're good if you caught that. Moving on. Go ahead and make this the one that has our clock rate, and we'll just do 9600. No shut the interface, and save our changes. Router 2, do the same thing. Interface loopback 0, IP address. Note that you only need the clock rate on one side of the serial connection, the DCE side. Okay, and if now I do show IP interface brief, I can see that it is up and up. Oh, no it's not. Now it is. It took it a little while to sync its clock rates there, I believe. So now that I have physical connectivity figured out, I can go ahead and test that to the bare minimum. So router 1 should be able to ping its loopback and the other side of its serial connection. Router 2 should be able to ping its loopback and the other side of its serial connection. Now note that router 2 cannot ping the loopback interface yet, nor can router 1 of the opposing router. So in order to enable this, we are going to use RIP. RIP version 2 specifically. So to do this, we're going to configure terminal on each router, go into router RIP, which will bring us into router configuration mode. We want to make sure we specify version 2. We also want to make sure we specify no auto summary. This allows RIP to send its LSAs, its link state arguments, I believe, to advertise the subnet mask, opposed to assuming a classful subnet, which we don't have. We're classless here. So with that in mind, we go ahead and add our network commands. Do this loopback and our serial interface, the same thing over here. Go ahead and get out of there. Now, what should happen is if I do a show IP route, I have one route found on RIP, that's what that R stands for. If you look at your table of contents here, R is RIP. And over here, I show IP route. Ooh, I don't have it. I wonder why that could be. I lied. It did not update its tables yet. That is one downside of RIP. Well, there's lots of downsides of RIP. I'll go into that in a separate video when we get into more advanced RIP configurations. But the amount of time it takes for it to send out its updates is way too long for a advanced production network to actually tolerate. All that aside, you can now see that each router has identified via RIP the opposing route, and it even tells you where it goes out of. It goes to 10.0.0.1 out the serial 00 interface, and router 1 goes out to 10.0.0.2 out the serial 00 interface. So let's test this. Router 1, can you ping 2.2.2.2? You can. Router 2, can you ping 1.1.1.1? You can. Congratulations, you have now configured your first RIP environment. This is just an introduction, and I'm going to go into a bit more detail about all these commands and stuff like that in further videos, but I just wanted to get you guys started and make computers and routers talk to each other. I hope it's been informative to you, and I look forward to giving you more information in the future. Thank you.